prediction and prevention of cardiovascular diseases. So I'm just going to cover 5 areas: the project background, the technology solution, and case study, and innovative highlights and application development. So, as we know, why cardiovascular diseases? As you know, it's well known, right? Cardiovascular disease is the #1 killer in the world. In 2021, that kills over 20 million people a year in the world. And unfortunately, China has the highest deaths of cardiovascular in the world. It's the #1 country, so unfortunately. And as you can see that the cardiovascular major caused by 3 areas of the major contributions of the death, mainly for the ischemic heart disease, or we call the stroke, and hemorrhage, and up counted to 82%. Fortunately, 80% of those diseases can be prevented if we do earlier enough. So that's why we are getting into this field. So this is so urgent, and everybody cares about it, right? So that's why I will let you know what's our approach to have an very earlier prediction and prevention and reduce the risks of the cardiovascular diseases, CVDs. As you know that currently, the most effective way to see if you have a cardiovascular disease is to use the image. The image can tell from the subclinic stage, and of course all the way to the clinics. But however, you can see it. But once you can see it by the image, that means you already have the disease. And the plaques, and especially the ischemic cardiovascular disease cannot be reversible, right? So that means you already have going way to the development of the disease. But however, if you can see earlier enough before the subclinic, and how can you do that? And use what we call the circulating marker, a circulating biomarker, starting from your genetics, your metabolic, and of course your protein markers. And you can see that, and you can early enough to detect your risk, and you can reduce that risk. And of course, you can really avoid getting into the subclinic, of course, now the further development of the cardiovascular diseases, right? So the circulating biomarker is very key. So here I want to introduce, there are so many circulating markers, and you can use that. But here I want to introduce you particularly as the, we call the 1-carbon metabolism. This particular 1-carbon metabolism can influence so many things in the aging, especially for the degenerative conditions, like we call the 1-carbon metabolism. So 1-carbon metabolism, actually here I introduce, will be covered 3 biological pathways, which is the methionine cycle, folic cycle, and the transsulfuration pathway that composed of the 1-carbon metabolism. So 1-carbon metabolism has a lot to do with the CVDs. I will show you 1 examples. So that's our technology to use the 1-carbon metabolism to develop the bunch of the biomarker panels, and use that detect and use the algorithm AI to assist your risks and do the early intervention to reduce the risks, right? So to do that, I just want to let you know that some of the markers that we use in our studies, this right there, you can see the methionine cycle, folic cycle, and the transsulfuration pathway. And some of the cycle, as you can see, that why is we call it 1-carbon, because that particular pathway that can donate the methyl group to very significantly in the pathway, as well as the epigenetics, right? So it's very, very important. I use this pathway. I use some of selected markers that directly relate to the cardiovascular diseases, and I use that as a particular biomarkers in this pathway. So, and also we know that, give you 1 example, for example, the three genes that we're looking at, one of the examples I show you. So this is Chinese population study. As you can see that for the one of the genes, that's MTHFR, as you can see from C677T, as you can see that one on the left, and this is Chinese population, and you can see on the left side, as with the high level of the homocysteine level, as you can see from the different variants, the change could be from 0 to 50%, just from the genetic alone, right? Not including the genetics also matters with the other metabolism involved. Just for genetic alone, you can see the influence, just to let you know. And we use this information and build into our program, into our algorithm, and further study that. So one of the major marker is the metabolic marker we call the homocysteine. Homocysteine is the molecular sulfur-containing amino acids that from the important methionine. So this marker is really, really important. What happens if this marker level is too high in that kind of methylation cycle, and you can see that cause some of the damage on your heart muscles and the lipid service that can damage that and build up a lot of this LDL, so that build a lot of this plaque, right? So this is individual separate factor in our system. And there's some of the clinical study shows right here. So for the Chinese people, especially for the men, if they're 50 years old, if they referred as a hypohomocysteine, so the hypohomocysteine, that means their homocysteine level, blood level is more than 15 micromole per ml, right? So that's called the HHCY. That means it's too high. So for the people like 50 years old, especially for Chinese old people of 50 years old, so the chance to get the cardiovascular is more than 53%, right? So it's really high. And also this hypohomocysteine is the individual factor. If every time if we increase 5 micromole per ml, so your death opportunity increased by 33%, right? So this is a really, really scary thing. So that's where we need to really make this under control, we should. So let's just give you one example that will give you example. Another one we call the GSH system. The GSH system is also a very important system. Okay, before I move to that, so the people in the industry recognize the hypohomocysteine as the number 4 highest risk compared to your hypertension, hypolipidemia, and hypoglycemia. So they call the 本来叫做3高，现在叫做4高 right? So that's why it's very important biomarker for the cardiovascular disease. Another system we call the GSH, glutathione system. Glutathione system is very important in the transsulfuration pathway. That the pool really gives you very good protection of your cardio muscle and your heart, right? If something is not right, if it's so depleted of your glutathione, and your cardio muscle will have the highest risk into the damage. Then it causes the part of the cardiovascular disease. So this system is very, very important to understand the whole science behind that and help us to design the panel that can well cover it from the genetics to metabolic and to this we call the GSH pool, so that we can make the whole system in homeostasis. Right, so that's the idea. So and then you can reduce the level of the homocysteine and keep the GSH level at normal, and then you can keep the risk really low. Take the risk of cardiovascular disease very low. So that's the principle that we come up with. So based on that, we use this called the BPO and GMDI. BPO and GMDI is the technology we developed at the science park, so that we have patented. We got this year. Took us about almost 3 years, 2.5 years to get a U.S. patent. This patent covers three things. Number one, they recognize that we promote the theory called BPO, biologic pathway omics. And then the second one, they call it GMDI, they call it genetic metabolic data associated intervention. And combine those three technology, and we can have over 12 different applications use this technology. Right? So I just want to show you this patent gave us a very good solid background. So we can use this patent technology, we design CARDIYON. So based on that, we just let you know what's this BPO means. So BPO is the biological pathway omics that based on the cell's three major pathway, we understand what's their interactions, how these interactions can affect our disease, can affect our health or aging. So we know this principle, then we use that one to design, we call the GMDI. And we use specific biomarkers as I used earlier, and that's just one example. We build up into our panel, then we test it, and we use algorithm to really associate the individual's risk into the individual's scores. Then we use the algorithm to spell out what kind of intervention we should use. And then we give you personalized intervention formulation. And then we give you a formulation to lower down your homocysteine and keep the GSH level high so that the whole system keep at a very healthy homeostasis. So that's the principle we use. So to do that, we designed this CARDIYON. CARDIYON basically uses technology, and we have three things, right? So we give this, choose this very good, well-designed biomarker, use AI algorithm to create the test data, and give you the index, we call it CARDIYON index. Based on the CARDIYON index, we give a different formulation and to intervene to lower the risk of the cardiovascular diseases. So this is a particular diagram that gives this design. And then also we give the personalized nutraceuticals, and also we monitor it before and after. And then we can see how well your risk will come down. And then we can see we can have this save your life and make you healthy. So the applicable people will be anybody over 35 years old, because sometimes the people don't know, right? They already have some damage in their vessels, they don't even know it. So if we don't taste it, you don't know it. Once we taste it, so you have much earlier knowledge, so you may have this risk and you need to lower that down. So that's the people over 35 years old, we recommend use this kind of approach. The second was people who already have the family history or genetic history of the cardiovascular in family members. The third will be the people who work on the very unhealthy lifestyle or working with very high stress work or life. So we recommend those people can use our approach and to lower down those cardiovascular risks. And let's just give an example how this works. So once we get this cardiovascular, or we call it CARDIYON index, and then the algorithm on the top, and really spell off where we should intervene and how much we should intervene to lower down the risks. Right? So this is the algorithm, and this is test results, and based on this mechanism, based on the pathway, and everything written down will come up automatically in your report, and then we'll give you the supplementation to lower down risks. And let's give you some examples, right? So that's personal supplementation over there, and this is just formulation right there, right? You can see that there's a lot of components right there, coenzymes and some of the formulation actives that can lower down the homocysteine level and keep the glutathione level at health conditions. Right? So there were so many combinations, over thousands of combinations. If we don't use the algorithm, don't use the AI, it's difficult to do the personalized. So just give one example. So this gave you one case study. As you can see, this person's in the beginning, this person's still in the 20s, earlier 30s. They don't even know the person really have the genetic variations. and he doesn't know, right? Once we tested it with his, you can see that the level is really high on the side. Then this is really high. You get a high risk. You get a cardiovascular disease, and the worst situation, you probably will die earlier, premature death. So then we lower down, use our formulation, lower down. You can say this risk is lower down. After a while, they keep the health conditions. After a while, the people think, okay, once it's lower down, I can just relax and just stop using this. As you know, you have a genetic variance, right? So there's genetic defect already there. If you don't pay attention, you just go like you did before, so the risk will go back up again. So after a while, realize that the risk is going up. Wait a minute, I need to reuse this package again. So you can see the risk coming down again. So this gave you one example to say if you once you start to use it, you might as well keep using it. Otherwise, the risk will going up again. Right? So the innovative highlights is it's very easy to do the sampling. It's home kit, and you can use the fingerprint, and just few drops of the blood, and then you can send it to us by mail, and we give you a report to you in a few days. Then we give you the solution. That means you get a genetic testing, metabolic testing, algorithm intervention, and monitoring. The whole thing comes as a package. Then, because we use this one carbon metabolism, that's really, really unique, innovative. Based on this coverage, we pretty much covered in all those mechanisms of this one carbon metabolism, and that one of the applications will address your heart disease risks. And finally, so we have this US-made nutraceuticals. We call them nutraceuticals, right? It's not a drug, but it's better than the supplement. We call the functional supplement. We call them nutraceuticals, which are proven to be healthy and safe and very effective. So all those four things combined, we believe was quite innovative. That's why we derive this technology from the US patent, and we get this kind of a solution for the CBD. So finally, I just want to say, what's the future applications? Because the one carbon metabolism I just showed you in the first slide, that has something to do with the healthy aging. So anything with the aging related to the conditions, this kind of approach can address, we believe. So for example, the first of all is the restenosis. Restenosis, that means you already have a stent. Once you have a stent of your calorie, most likely you will get you get a restent again. So we can look at the risks and then really lower down the risks and lower down the chance you get a restent. Right, the first another applications. The second one is the cognitive impairment and dementia. And then we can see some of the applications we can do it. And this application can be used for that. And we have the product. We want to extend it to some more clinical studies and extend it to the dementia applications. The third one is for the macular degenerative, where you have eye problems because of a degeneration. And we want to use that as well. And the fourth one, you probably don't know, or guys probably know that. Most of the erectile dysfunction is caused by two factors. One is the psychological, another one is your cardio problems. If your cardio problems get blocked out, most of the time you probably have erectile dysfunction. That applications will be leach applications, and we have a product to address that as well. Last one, not the least one, is the oxtail maturity and embryo development. So we find out a lot of clinical studies that find out if those levels, folic acid and homocysteine levels, is out of control in the health range, your egg quality is not good enough. You need to make a control before you get pregnant and during the pregnancy as well. So those four, at least, further applications, we can extend CARDIYON into the healthy lifespan or anti-aging areas that we plan to do, right? This is a future development. So because we only have 20 minutes, so I want to finish earlier. So on time, So finally, who we are. So we are the biotech company located in the Hong Kong Science Park. So basically we have 4 different platforms. We have a very good US patent as a technology as a background. So basically we're addressing the aging-related conditions and some diseases. We can prevent it, we can prevent it, and we extend the health lifespan. And currently we have 6 areas we are looking at. So this is just one of them, cardiovascular, right? So I just want to finish up very quickly. I want to show a short introduction of our product, new product, CARDIYON, and hopefully we can use this for larger population use and get a better data to support our innovative approach to help people out there. Thank you. Yeah.